Welcome to Pavinar's webinars for the pavement community. My name is Andrew Bram, and today we're going to talk about potholes, the who, what, where, when, why, and most interestingly, how of potholes. So we'll start with the background. That'll cover the who and what is a pothole and a why do we care. We'll talk a little bit about pothole formation, which is the where and the when do potholes form. And then we're going to talk about how to avoid and fix potholes. And this is the how we can avoid potholes and how we can fix potholes. Finally, I will show some additional resources, both from some state level work and also some national level work. So potholes, who are they? Well, if you look at rigid pavements, the FHWA Distress Identification Manual only defines potholes as a flexible pavement distress. Now, when looking at rigid pavements, cracking, joint deficiencies, surface defects, and patch deterioration may all create pothole-like distresses on a rigid pavement, but all of those are discrete distresses that are not under the pothole umbrella. Therefore, when we're thinking about potholes, it is only for flexible pavements if we look at the FHWA Distress Identification Manual. And they are defined as bowl-shaped holes of various sizes, and they have a minimum planned dimension or diameter of just under 6 inches, so 5.9 inches. And as you can see on the right, we have a picture of a low-severity pothole. And you can find out about all of this if you search online FHWA.HRT.13.092, and that is the FHWA Distress Identification Manual. So what is a pothole? There are 3 severity levels for potholes, then they are based on depth. A low severity pothole is less than 1 inch. A medium severity pothole is 1 to 2 inches, and then a high severity pothole is greater than 2 inches. And FHWA quantifies the number of potholes over an area at each severity level. And so you're looking at counting the number of potholes, 1, 2, 3, or 4 potholes over some area, 1 square foot, 9 square feet, 1 square meter, at each severity level. So you have 3 low, 1 medium, 0 high, whatever, over an area. And the minimum area you're supposed to look at is 0.2 square feet. Now we look at why potholes are important. Well, if we look at the American Automobile Association, or AAA, and some data they collected in 2021, they said that approximately 1 in 10 drivers have damaged their car by hitting a pothole. So 10% of drivers in the United States have damaged their car hitting a pothole, and the average cost of repair is $600. Therefore, if you look at all of the vehicles that have hit a pothole over a year in 2021, they estimate the total cost of pothole damage just to vehicles is $26.5 billion. So that's a very large number, and you can see very quickly why potholes are a very important issue and why many agencies have developed pothole hotlines and have designated pothole filling crews. Now, there are pros and cons to having these designated crews. Some people say it's too reactive and you should go for a more systematic approach. But at the end of the day, a lot of cities have found success with designated crews who go out and simply fill hot potholes every day based on where people report them in their municipality. So what can we do as engineers? Well, we can do proper design and proper maintenance of our roads. And we'll talk about that in the 3rd section of this Pavinar. But next we're going to go to pothole formation. So how do the potholes actually start forming? The where of the potholes. Generally, it's in the wheel path. You need some sort of loads in order to have a pothole start forming. And you can see a pretty highly distressed pavement here, and I would assume that some potholes will start forming shortly on this roadway. Now, I've got a little asterisk next to the generally, and that's because there is one big exception, and that's where you have either poor longitudinal or transverse joints. If you have poor longitudinal or transverse joints, it may just start deteriorating without even any wheel applications, and you could start getting potholes. And of course, there are other mechanisms, but in general, from a design and maintenance standpoint and a planning standpoint, we need to be worrying about the wheel path. And there's multiple mechanisms behind the formation of potholes. So when do potholes form? Water is the common denominator. You'll notice that a lot of the pictures in this presentation, I've just went online and got a whole bunch of different ones. The vast majority of them have water in them. You also could have a poor subbase or base course. You could have improper structure and improper pavement structural design. And you could have construction issues. That goes back to the longitudinal and transverse joints and some other issues that we'll talk about. And then finally, all of these type of things can lead to cracking. And at the end of the day, you have cracking and those cracks turn into potholes. Now, I do want to note that water is listed first here. Water is a common denominator. And let's keep water in the back of our mind because we're going to talk about that quite a bit more later in this Pavinar. But let's go into a little more detail about the last four. So a poor subbase or base course. This can be either a weak base layer, an unstable base layer, or a failed base layer. This can be because of the materials or it can be because of constant saturation. If you have consistent or constant saturation, you lower the strength of your base layer or your subbase layer, and that can potentially increase deformation. You can have expansion and contraction of your weak, unstable, or failed base layer, and this comes from either moisture and also moisture within freeze-thaw cycles. A lot of this stems from the fact that the subbase or base has poor drainage issues. And I want you to notice that a lot of the things under the poor subbase and base come from saturation, moisture, and drainage. This all revolves around water. You can have an improper structure, so your structure can just simply be too thin. Again, you can have a poor subbase or base. If you design for a certain quality subbase or base and you're not achieving that, then your structure is compromised. You can have some unexpected heavy traffic, so during pavement design, the type of traffic that goes on there is very important. Often you'll see potholes form rapidly on roads that maybe lead to a construction site, a new neighborhood being built or a new building being built. That's because of those very heavy traffic, heavy truckloads driving over a road that simply was not designed for it. You could have some sort of compromised materials, so at the plant it's either heated too much, you could have some moisture in there which will lead to stripping, and then you can have delamination. Delamination is where you try and tack coat or glue your pavement layers together. Flexible pavements are built in layers. Those layers have to be glued together. If they are not glued together, you'll have issues. And that causes delamination, and that's either an improperly placed tack coat or a failed tack coat. And again, I just ask you to take a look at the concepts of stripping and delamination. These can both be caused by moisture. So moisture is a very important issue. Now you can have the best materials in the world, you can have the best design in the world. If you have poor construction, you're going to have issues. And there's a couple things that you want to look out for. One is the asphalt mixture segregation, and this can be either physical or thermal. So physical segregation is where larger particles in your mix get all isolated in one place. In this picture, they're kind of along the center line there. There's probably some sort of issue with their augering system or something in this paver. Thermal segregation is where a lot of your mix is cooler and a lot of your mix is warmer, but you have some sort of significant temperature gradient, and that, of course, is going to impact your compaction. So you want to have your mat at a very consistent, very specific compaction temperature, and if it's not, you're going to get improper compaction. You can also get improper compaction with poor rolling patterns or something along those lines. Poor longitudinal joints can cause potholes. If you want to see some great potholes, come on over to the city of Fayetteville, Arkansas, and drive down Maple Street. There's a right-hand turn lane that turns right into Arkansas Avenue, and that is just a haven for potholes. They fix it all the time. They put overlays on. They fill the potholes. Those potholes just keep coming back. So, got a great example here in Fayetteville, Arkansas. Then also, if you have deleterious materials in your mix, that can cause weak spots. Those weak spots fail and potholes can start forming there. So obviously, you always need to be very careful with your construction. and have proper construction practices. Now, all these things at the end of the day usually lead to some sort of cracking, and you need cracking in order to get potholes. So the accelerators of cracking are both age and oxidation. It can also be all of the issues that we talked about before, the poor subbase, the moisture, the construction, all those type of things. And you can have longitudinal cracking. You can have transverse cracking, low temperature cracking, which is also called thermal cracking, edge cracking, reflective cracking, and block cracking. And then you can see here in this picture, you have some longitudinal cracking, you have some transverse cracking. That's called alligator cracking. And what happens is you can see here, and you've seen in previous pictures, there's small little sections of asphalt that are just sitting there, the little islands. Once those start popping out, that's where potholes start forming. So if you start seeing longitudinal and transverse cracking joining together like this, and you start seeing alligator cracking, very high probability that you'll start getting potholes, because those little chunks of asphalt that you see will just start popping out, and that's where your pothole will form. So we talked a little bit about formation, but what can we do to ideally avoid, or if necessary, fix potholes? Now, I said it before previously, the biggest thing we can do to avoid potholes is keep the water out. And there are two things that are very, very easy that we can do in order to do this. First is you keep the surface of your pavement sealed, which means applying some sort of surface treatment. It can be a chip seal, it can be a slurry seal, it can be microsurfacing. Those type of treatments allow the water to hit the pavement surface and run off the pavement surface and not go into the pavement structure. It's also very important to maintain drainage. This can be drainage that is installed with the construction. It can be the drainage in the ditches next to the pavement. But if water does get into the pavement structure, you want it to be able to quickly flow out and go away from the pavement structure through whatever sort of drainage mechanisms that you may have. You want to have a proper structural design. This includes a functioning and high quality subbase or base. You may need to stabilize your subbase or base with either asphalt emulsion, asphalt foam, or Portland cement. You want to make sure you have a thick enough pavement structure for the loads that are being applied, and you want to make sure you're predicting the traffic properly. You also want to have proper construction, so you want to clean any sort of existing pavement that you may have and make sure that you have a nice, even, clean surface that you're placing your new asphalt mixture on. And I would always recommend having an MTV, a material transfer vehicle. This avoids segregation. It avoids both thermal and physical segregation, because asphalt mixture goes from the truck into this machine, and there's just basically a giant pug mill in there, and it remixes the mix immediately after coming out of the truck and places it in the paver, which means you have a nice, homogeneous, both physically and thermal, segregation going directly into your paver. These are extremely beneficial pieces of equipment. You want to make sure as you build your flexible pavement structure up between those asphalt layers, you put a good tack coat. And I have an entire Pavinar on tack coat. If you're interested in learning more about that, I encourage you to check it out. And then during compactions, you want to have good rolling patterns, and you want to make sure you're getting good joint compaction both longitudinally and on your transverse joints. At the end of the day, doing all these things should minimize cracking. If you minimize cracking and you're keeping that water out, you should minimize potholes. But there are potholes out there. There will be potholes that are formed out there. What can we do about them? So we're going to talk a little bit about the materials that go into fixing potholes. We're going to talk about the various techniques that go into fixing potholes. Note the water in the lower left-hand picture. And we're going to talk about what type of equipment can be used in order to fix potholes. So when we're talking about materials for fixing potholes, let's talk first about hot mix asphalt. And this is considered the best type of material. And what hot mix asphalt does is it follows generally your surface or binder course specifications. So in your area, you place surface courses of asphalt mixed down. You have some sort of specification for those surface courses. You usually use that specification for the hot mix asphalt that's placed into potholes. Now, some potential issues with hot mix asphalt is you can get thermal segregation, especially if you just have a truck of hot mix and you're driving down a road, putting little shovelfuls into each pothole, you can have thermal segregation. It's also very difficult to get good density once the mix is in the pothole. Asphalt mixtures need to have proper density. And putting material in a relatively confined, isolated area and trying to get a good compaction on that is very difficult. And then also permeability is an issue. We've been talking a lot about water. It's hard to get that good density. It's hard to get that sealed. If water gets into the system, chances are another pothole will form in probably about the same place. Now, there is a lot of cold mix asphalt used as well because it takes care of the thermal segregation. It allows for a truck to go out in the morning with a bunch of mix and then come back in the evening empty, and you're not going to have that thermal segregation. Your mix isn't going to cool as the day goes on. And there's three types of cold mix that you can use. One is you can make a truckload of cold mix at your local plant, just like putting it through a hot mix asphalt plant, but instead of putting in hot asphalt binder and heating the aggregate up, you just mix emulsion with cold aggregate or ambient temperature aggregate. There's very specific agency specified pothole mixes, and then there are proprietary pothole mixes as well. The nice thing about cold mix asphalt is it generally requires less tack and less compaction versus hot mix asphalt. However, you do need to consider curing issues. Usually there is some sort of material in that cold mix asphalt that prevents it from breaking quickly. That usually needs to cure out in some way. And then finally, also you can have issues with stability because it takes a little longer to cure. It might move around a little bit more in that pothole. And it generally doesn't have quite as good adhesion and cohesion as hot mix asphalt. Now, I love cold mix asphalt, so it kind of hurts me to say that, but we do need to recognize that the adhesion and cohesion characteristics of cold mix asphalt materials are different and generally not as well as hot mix asphalt. Three other type of kind of categories of material for spray injection. You have emulsion and crushed aggregate. It almost forms like a slurry type material, and the equipment is key. We'll talk about that more in upcoming slides. You can have resin-based pothole patching material. It has a very high cost, but it's actually very good for low temperatures. And then also you can place various additives into your material. For example, anti-stripping agent is recommended. That could be anything from 1% lime, it could be silicone-based, it could be a chemical anti-stripping agent. But there's also various other additives, especially if it's a proprietary material, that enhance performance, or at least are supposed to enhance performance. So techniques, you've probably seen this a lot. Two guys in a truck, the truck's just going down the road slowly, they've got a couple shovels, they're tossing the mix into the hole, and they just go down the road. The truck may back up into the other truck, or the truck with the material may back up, kind of do a little bit of compaction. But this is called throw and go or throw and roll, and it's very, very common. And you place either hot or cold mix asphalt into the pothole, the truck compacts it to a slight crown, and then you're open to traffic, you're good to go. Semi-permanent, we're kind of stepping it up here in quality of patching. That's where you remove any water or debris, you saw cut squares, you apply your patch, and you use a little vibratory compactor in order to get a little bit of density in that mix. Permanent patching, this is the gold standard or the Rolls Royce. It's similar to semi, where you cut outside the worn area. So you actually cut into good pavement, which means you're getting rid of all your bad pavement. You remove all the material down until you get to a stable base. So these can be much wider, these patches, and much deeper than a semi-permanent patch. You then put tack coat on the bottom and on the sides, so you make a nice, good little like bathtub full of tack coat. And then you place the material in and you compact it. And this really is the gold standard. And if you do a permanent patch well, that will last as long as the rest of your road. Because you got your density, it's glued to all the other surfaces, water's not getting in, so you're good to go. Now, edge seal, this is very similar to throw and go, but it does require tack. So I probably should have put this up by the between the semi-permanent and the throw and go. But you just put a little tack coat in there, and then you throw material in. It's kind of a step up from throw and go, but it's not quite as good as semi-permanent. Now, I do want to spend a little bit of time on spray injection because you do need very unique equipment and you need unique material. So you have a crushed single-size aggregate and you have emulsion. And like I said, this kind of creates a slurry. And what happens is you have a very specific piece of machinery, which we'll talk about in a minute, but it gives you a wide range of performance. So it's nearly equivalent to permanent repair if everything is done right. There's been a lot of research done on spray injection, but if you do everything right, it's nearly equivalent to permanent repair. But other studies have found that you can have lack of density, you can have issues with the equipment clogging, you can have spraying issues. So spray injection, although not new, there's been quite a robust movement toward this area. And one of the big reasons is, you can see in this picture, instead of two guys with a shovel or two gals in the shovel behind a truck, you have one person. And it can just be done with one person, which is a huge advantage because you immediately decrease your workload by 50%. Now, of course, specialized equipment is required. Now, some of these patching pieces of equipment have very large blowers on them, which can remove water and dirt. Then you can spray a tack coat with the piece of equipment. Then you spray the pothole mix. Then you spray cover aggregate. So you kind of have like a buffet of materials on there, and you pick and choose what you want to do. You can clean it out. You can put just tack down. You can put the pothole mix. Then you can put a little bit of cover aggregate on there. And there are different types of spray injection devices. You can have an air delivery method. You can have an auger method. There's some others out there, but an air delivery method is recommended. Now, it is also important to note that there is training required, and it takes about 4 to 6 weeks. These are extremely powerful, extremely functional pieces of equipment, but with that requires a very good insight on how to use it. Now, I do want to talk about a little bit of efficiency, how many minutes it takes to do a pothole, and you can see immediately why throw and go is the most popular. It's the fastest, and it's by far the cheapest. You don't need a piece of specialized equipment. You need a truck and a couple shovels. Spray, it's about the same speed as a throw and go, but you require a very specific piece of equipment. And a semi-permanent takes a little bit more people, takes a little bit more time. Of course, that's going to increase the costs. Now, there are some more innovative solutions out there. For example, we do have some infrared technologies, and this is where you heat the damaged areas with an infrared heating machine. You remove all that heated material, you mix it with new asphalt binder and a rejuvenator, and you return the material to the hole and compact it. So this is a very robust system. It's a very comprehensive system. It also takes a lot of time. It takes about 20 minutes per pothole. You can do something similar with microwave. This is where the damaged area is heated with a microwave, and then you also heat wrap with the microwave that you're going to place in. You put the wrap in the hole, you compact it. Again, there are some benefits to this. You're getting things to higher temperatures that tend to lead to better compaction, but it does take a long time. They estimate about 50 minutes a pothole. So we talked about throw and go, we talked about semi-permanent, we talked about permanent, spray, infrared, microwave. What is best? Of course, it depends. Depends on the weather, the time of season, the lane location, the size of the pothole, the money you have available, the equipment you have available, the personnel you have available. The list goes on and on. And I think this is one of the reasons why pothole repair kind of continues to be such a challenge. You want to do it quick, you want to do it well, and those two are very, very hard to balance. So it's kind of interesting. I think there's been a little reconnaissance here in pothole research, as you'll see. So it's interesting to kind of see what's happening and to follow the progress that we're making. Now, for fixing potholes, what kind of equipment you do need workers. So in general, for like throw and go, for kind of the basic ones, you need 2 workers. You need a truck, you need some hand tools, a shovel, a tamper, maybe a broom and a brush if you got an elite equipment list to get excess material out. If you're doing more advanced work, the semi-permanent and the permanent, you'll also need a saw and a jackhammer and an air compressor, some sort of compaction device. This increases the number of workers you need, especially if you want to keep moving down the road. Maybe you can have one crew sawing, jackhammering, and clean them out, and then the next crew place and mix. But it's going to take either a little longer or it's going to take some more workers. If you have hot material on site, you're going to need some sort of hot box. So if you're using hot mix asphalt, this keeps the material hot. And there's two different types. You can either have a holding tank, which is basically just like an insulated tank. There's no heating source, but it does help keep material warm. Or you can have what's called a reclaimer, and this is thermostatically controlled. This is basically a small oven, and it keeps your material warm. And then again, just to reiterate, for spray injection, it takes about 2 workers. That's because there's one driver and one person with the boom in the back. So you need 2 workers and a specialized truck. So that's kind of the different equipment that you need. And I kind of want to finish the avoiding and the fixing potholes by simply saying what is the best way to fix it. That's to avoid formation. Keep that water out and good construction practices. That will go so far in keeping the number of potholes down. And I know they're out there, and I know as an academic it's easy for me to say this, but if you're spending a lot of money on pothole repair, I do ask you to consider, are there small things that we can start on in the front end that will help avoid the formation of these potholes? All right, we're going to go from avoiding and fixing potholes to some resources. So we've got some work from the University of Illinois. If you search FHWA-ICT-21-003, this was done by Hodge and Liu. They talked about materials, techniques, equipment. They had some very nice sections on field practices, and they also had some local meetings and took good notes during that. This is a very nice free to download resource, and this was put out in 2021. A little bit older in 2018 from the University of Minnesota, Ghosh et al. If you search LRRB report 2018-14, when I searched that, it wasn't the first thing that popped up. The summary was the first thing that popped up. But if you do a couple clicks, if you look a little bit, you can find the full report. I think it's about 120 pages. It's got a great lit review. Has some interesting pothole stress analysis. So they did a little bit of analysis on the stresses and strains that are applied when potholes are formed and filled. Talked about some new materials that you may need to place in there. Something I really liked about this report is proactive preservation activities. For those of you who've watched other Pavinars of mine, you know how much I love pavement preservation, and so I'm really happy that the University of Minnesota put something in their report. And then the third one, it's from New Jersey. It's Wong and Chen. If you search FHWA NJ-2024-001, again, they got a great lit review. They talk a lot about field performance. Something I liked about this study is they have a very nice life cycle cost analysis. So if you're interested in, well, throw and grow is cheaper, but it's not going to last as long. What would it cost to go up to a semi-permanent patch? And how much longer would that last? How much money will I save in the future? They go into that in their life cycle cost analysis. They also talk about some field and lab experiments they ran, which was very interesting. And they also had some numerical modeling. But there is more research in addition to the national level. Now, I'm originally from Wisconsin, so I do have to point out that all 3 of these universities are in the Big Ten. Just saying. But looking at a national level, if you search NCHRP Synthesis 463, this is pavement patching practices. This was put out by Becky McDaniel and her group in 2014. She was a phenomenal researcher. Anytime you see McDaniel on a report, you know it's going to be high quality, no question. They start with their literature review. They had a very nice survey response. They do a very good job of summarizing state practices. So what are other people doing out there? And they also had some case examples, which is it's a great document. And it's getting a little old, but again, great document, and those topics never die. They're all good, high quality. And I also want you to keep an eye out for NCHRP Synthesis 20-05, topic 56-16. Now, if that doesn't put you to sleep, I don't know what will. But if you search data collection and management to expedite pothole repairs, currently I'm recording this in 2024. It's due to be completed in late 2025, but maybe if you're watching this in 2026, go ahead and search for it because I'm sure it'll have a lot of interesting information on it. Just like anything that Becky McDaniel wrote, anything that comes out of NCHRP, you're pretty much assured a solid, comprehensive document. So summary of potholes, we went over the background, how they form, how to avoid potholes, I'm a big fan of that, and how to fix potholes. and then some additional resources if you are interested. So I thank you very much for joining me, and I hope you have a wonderful day.